What is a Btrfs file system? Why should we use it and how? What are the limitations? What could be the benefit with PostgreSQL? And I hope after you attend this session, you should be able to create a Btrfs subvolume snapshot and perform instant cloning of a PostgreSQL cluster. Sorry. So what is Btrfs? Btrfs stands for B-tree file system or better file system. It's a file system based on the core principle, copy on write. It was initially designed at Oracle Corporation. Btrfs 1.0 was originally slated for late 2008 release. And in 2012, two Linux distributions moved to production. Oracle Linux in March and SUSE Linux Enterprise Server 12 in August. And since when, Btrfs was adopted as default file system for SUSE Linux Enterprise Server. So let me give you some feature. Online volume growth and shrinking. Btrfs file system resize, plus or minus. Online block device addition and removal. Btrfs device add or delete. Online balancing, this is a nice feature. Btrfs file system balance. When you want to add a device to a file system, you use this command to balance your data across the two devices. And SSD optimization, this is default as SSD drive are auto-detected. Some more feature with subvolumes, atomic writable via code or read-only snapshot of subvolumes, truly massive max file size up to 16 exabytes, online defragmentation. It is a mount option, so you have to add it in the /etc/fs tab auto defrag option. The compression is also a mount option. You just have to add compress equal zlib in the etc/fs tab. Support, Btrfs is supported as root file system, but also for migration from ext2, 3, and 4. And everything you can do with the YAST partitioner is supported. YAST is the graphical GUI to configure and set up the OS, SUSE. One exception for RAID device, compression and encryption is not possible. Subvolumes. Btrfs consists of one or more subvolumes. Btrfs subvolumes have always a number and a name. Always at least one subvolume which is root and has a number 0. And a subvolume can include a complete file system tree. The benefits of this is that subvolumes can have different attributes as quotas, snapshotting rules, and mount option, as we have seen in the previous slides. So copy on write go. With a normal write, existing blocks are overwritten when the content changes. But with copy on write, existing blocks, once changed, are stored alongside the original blocks. Only the metadata block list is changed. Benefit of this transactions implementation is possible because you have always the old content. So a short animation with a normal write, sun is shining. When we want to modify this with sun was shining, you see that the block is overwritten with was. But with copy on write, sun is shining and the next block is free. In this case, with copy on write, the block is remaining as is, but the next block is modified with was. So the old block is always there. Instant cloning. What is instant cloning and how to set it up? Instant cloning, it's an exact copy of your Postgres cluster. Changes must not affect the original cluster. It must not also impact the service, and it must not impact the performance. And obviously must not take a lot of time. So, demo preparation. The following slide will help you to reproduce this demo. So, I will start with a minimal installation of /15. I will create a user and group as usual, and I add this user to the sudo configuration because in this case I don't have to switch from root and Postgres. I install the required package for the compilation and I prepare the Postgres installation. I download and install the Postgres SQL 12.4 and I create a new Btrfs file system where will the data reside. I will use mkfs.btrfs even if it's not recommended by SUSE, which prefer to use YAST. But we see that, or we know that behind the scene we use the same command. I create a new Btrfs subvolumes, and then I create and start my cluster. So I will use pgbench for my test and create a new database of 15 gigabytes. And while, or in another session, I will generate some load with using again pgbench. And while the load is running, I will create the clones to show you that it does not affect the productive. And a clone of the clone. So let's go live to the demo now. And in my first session, I start. So you see, I have a file system /pgdata, which is a Btrfs file system, mounted on SDB1, which is 50 gigabytes. And I have also underneath a subvolume pg1, where the PostgreSQL data are. I start my cluster to be cloned. Okay, let's start it. I drop and recreate my DBI database for our test. And I have generated already this data because as it takes about 10 minutes to generate all this data, I did it in the background. So now my database is 15 gigabytes and I have 4 tables in it. I got no access to the user DBI. And now I start to generate some load on this cluster with 16 transactions per second and 16 simultaneous user. Okay, now I go on the other session and I will create my clones. So I create my first clone, staging, and you see that it took no resource on the server. And we can check here that the transaction per second is around 60, always the same. So let's create a second one, which will be the test. Again, it took no resource on the source cluster. You can see it's still around 60 transactions per second. So now we have 2 clones and 2 new subvolumes. For fun, I will create 5 other clones in a loop. And you see, it's immediate. And again, no impact on the resource. We see that we have still around 60 transactions per second. So now we have 7 clones and 7 subvolumes. Now I will start the first clone, staging. And in order to do that, I have to remove the postmaster.pid. Why? Because as it is an atomic snapshot, everything has been copied in this directory, and even the postmaster.pid, which contains the process ID. And as you might know, we can't start 2 clusters with the same PID. So I remove it, and there's something else to do. We need to change the port, of course, and I echo the new port in PostgreSQL.auto.conf. Now we can start. And we see the database system was interrupted, so he has to process an automatic recovery because it was as if we have killed the process. And you see now our clone is started. The first clone is started. Now let's do the same for the second, the test clone. Okay, I again change the port and I start. And again is processing an automatic recovery. So this one will take some more time, I think. But it's not, yeah, now it's over. So we see that we have two clones up and running plus our source. So let's make the first test. We check the content and the number of rows of the PG bench Taylor table. We see on the source that the filler is blank and we have 10,000 rows. On the staging, the same. And on the test clone also. So now, for my test, I will update this table. The first one with I'm the clone of PG1 and 10,000 rows have been updated. And for the second, the test, I'm the second clone of PG1 and also 10 rows have been updated. But additionally, I will remove some rows from the test clone, more than 9,000. Let's check again our cluster, source cluster. The source, the field is blank, and we have still 10,000 rows. On the staging, we have the filler updated with I'm the clone of the PG1 and 10,000 rows. But on the test clone, the filler has been updated also. I'm the second clone of PG1, but remaining are only 301 rows. So you see the source has not been impacted by my modification. In the second test, I will create a new table and insert 1 million row. And we can check here that the number of transactions per second is always the same, around 60. So you see that 1 million rows have been inserted. And when we check the clone test, we see this table. Oh, sorry, this is the source. Oh, no, first the test. So you see the user table, and on the source, the table has not been here. So now, to show you that if the tests are work, we can stop the clone. Stop them. Okay, take some time. And if as we don't need them anymore, we can remove them. So with Btrfs subvolume delete, I remove my two clones, staging and test. And in a loop, I will remove all of them. You see, no impact on my source cluster. So we make a last check, and we see that on our file system PG data, we have only one subvolume, which is PG1, which is the source. And one last check on this. See that our database is there, and it has still our 4 tables. So my demo is over, and I will go back to the slides for the conclusion. So instant cloning a Postgres cluster with Btrfs is easy and straightforward. For developers, of course, validation procedures, rapid testing, and even PostgreSQL upgrade. Advantages: easy setup, you don't need license, there is no impact on performance, and doesn't affect the source cluster. One disadvantage: Btrfs unfortunately is not supported on all Linux distributions. So, Mark, I'm over. Do you have any questions?